West African ancestry doesn't produce just the fastest sprinters. It produces the highest circulating free testosterone of any measured population, driven by androgen receptor polymorphisms that no supplement protocol can replicate. The androgen receptor gene sits on the X chromosome at XQ1112. Its first exon contains a CAG trinucleotide repeat that directly determines how aggressively the receptor binds testosterone. Shorter repeats mean higher transcriptional activity. Longer repeats mean weaker signaling. A large-scale genotyping study across 4 ethnic populations found the hierarchy is consistent. Afro-Caribbean men carry the shortest CAG repeat lengths and the greatest predicted androgen receptor activity, followed by Caucasian, then Hispanic, then East Asian men, carrying the longest repeats and the lowest predicted activity. The differences were statistically overwhelming across every pairwise comparison. This is not a subtle trend. It is one of the strongest ethnic polymorphism gradients in human endocrinology. A 1986 study in the Journal of the National Cancer Institute found young black men had 19% higher circulating testosterone than age-matched white men after controlling for body weight, alcohol, and smoking. But the receptor polymorphism means even identical testosterone levels produce stronger anabolic signaling in tissue with shorter CAG repeats. The hormone is half the equation and receptor is the other half. West African. The testosterone advantage compounds through SRD5A2, the enzyme converting testosterone to dihydrotestosterone. DHT binds androgen receptors 5 times harder than testosterone. Men of West African descent show higher 5-alpha reductase activity, meaning more testosterone gets converted to the more potent androgen at the tissue level. Shorter CAG repeats plus elevated DHT conversion creates an androgenic environment that sits at the ceiling of what human endocrine architecture can produce naturally. No exogenous protocol replicates this without suppressing endogenous production. The machinery that drives superior androgenic signaling is encoded, not injectable. Men who supplement testosterone exogenously shut down their own latex cell production through negative feedback on the HPG axis. Men who inherit short CAG repeats and elevated SRD5A2 activity get a permanently stronger signal without suppressing anything. The architecture runs hotter from the factory floor. But the hormonal advantage of Ancestry is not limited to androgens. It extends across every axis of the male endocrine system. East African Highland populations show a cortisol regulation pattern that most optimization protocols spend years trying to manufacture. Baseline cortisol runs lower. Cortisol clearance after acute stress runs faster. The net hormonal effect is an environment where testosterone is not chronically suppressed by its primary antagonist. Cortisol and testosterone compete for the same precursor molecule, pregnenolone. When cortisol demand is high, pregnenolone funnels toward the HPA axis, starving the HPG axis of raw material. A 2004 study in the European Journal of Applied Physiology found that elite Kenyan runners showed lower cortisol responses to identical exercise stress compared to European controls. The hormonal economy is leaner. Less cortisol waste means more substrate available for testosterone and its downstream metabolites. Men chasing hormonal optimization through ashwagandha and stress reduction protocols are trying to simulate what this population carries at baseline. The cortisol advantage is not just about recovery. Chronically elevated cortisol degrades androgen receptor sensitivity over time. A system that clears cortisol faster preserves receptor function longer. The downstream testosterone benefit compounds across years, not just workouts. South Asian men carry a hormonal profile the optimization community chronically misreads. SHBG levels tend to run lower than in European or East Asian populations. Lower SHBG means more free testosterone available at the tissue level. That sounds like a clean advantage until CYP19A1 enters the picture. Aromatase gene polymorphisms in South Asian populations associate with higher estrogen conversion rates. More free testosterone gets aromatized to estradiol before reaching the androgen receptor. Combined with higher rates of visceral adiposity, which concentrates aromatase enzyme in abdominal fat, the net hormonal picture is a system primed for conversion rather than retention. But the catch cuts both ways. South Asian men who maintain low body fat and high insulin sensitivity effectively unlock a free testosterone pool that higher SHBG populations cannot access at all. The architecture favors conversion. Lifestyle determines which direction. This is why body composition interventions produce disproportionately large hormonal returns in this population compared to almost any other. Northern European ancestry solved a hormonal problem that cripples testosterone production in every indoor-dwelling modern male. Depigmented skin synthesizes vitamin D at rates up to 6 times faster than heavily melanated skin at equivalent UV exposure. Vitamin D is not a vitamin. It is a costeroid hormone that directly regulates genes governing testosterone synthesis in latex cells. A 2011 study in hormone and metabolic research found men supplemented with vitamin D for 12 months showed increases in total testosterone, free testosterone, and bioactive testosterone compared to placebo. Northern European skin pigmentation is an ancestral adaptation to low UV environments that creates a hormonal advantage in exactly the condition most modern men now inhabit. Indoors, under artificial light, chronically deficient. At latitudes above 37 degrees north, darker skinned populations synthesize functionally zero vitamin D from sunlight for up to 6 months per year. The testosterone cost of that deficiency accumulates silently across every winter. Most men supplementing 5,000 international units daily are attempting to close a gap that lighter-skinned northern populations never open. The skin is the original hormone optimization protocol. Mediterranean populations carry a DHEA to cortisol ratio that creates a natural anti-catabolic buffer most men chase through supplement stacks and adaptogens. DHEA, dehydroepiandrosterone, is the most abundant circulating steroid hormone in the male body and serves as a direct precursor to both testosterone and estrogen. Studies on Southern European male populations have documented higher baseline DHEA sulfate levels compared to Northern European controls after age matching. DHEAS declines at roughly 2% per year after age 30. Populations starting with higher baselines reach clinically relevant thresholds later. The practical implication is that the hormonal aging trajectory runs slower. A 45-year-old Mediterranean male carrying DHEAS levels equivalent to a 37-year-old Northern European male is not aging better on paper alone. His testosterone precursor pool is deeper, and his cortisol buffering capacity is stronger. The architecture does not resist aging. It delays the inflection point where decline accelerates. But here's where it gets interesting. Pacific Islander. A 2016 study in Nature Genetics identified a missense variant in the CREBRF gene that occurs at a frequency of 26% in Samoans and is virtually absent in every other global population. The medical framing calls it an obesity risk gene. The endocrine framing tells a different story entirely. The variant selectively decreases cellular energy expenditure and increases fat storage efficiency. In a population shaped by ocean migration and periodic famine, that adaptation kept people alive. But the downstream hormonal effects are what the optimization community has missed completely. A 2222 study found that Polynesian men carrying the variant showed lower circulating myostatin, the protein that caps muscle growth. Lower myostatin means the genetic brake on hypertrophy is partially released without any pharmaceutical intervention. Samoan infants carrying the variant showed higher lean mass and bone density alongside higher body fat. The muscle density visible across Pacific Islander populations is partially growth hormone mediated, not purely androgenic. This is why Samoan athletes routinely carry body compositions that seem impossible relative to measured testosterone levels. The anabolic signal runs through a different channel, one that Western endocrinology, fixated on the testosterone to estrogen axis, has missed. The variant also associates with improved cognitive performance in older adults, contributing nearly 6 times more to cognition scores than APOE. The gene the medical establishment labeled a disease risk is looking more like a multi-system performance variant that does not fit the Western metabolic framework. East Asian men carry the longest average CAG repeats on the androgen receptor, the highest SHBG levels of any major population, the lowest 5-alpha reductase conversion activity. By every metric the optimization community obsesses over, this looks like a disadvantage. The longest CAG repeats mean lower androgenic signaling per unit of testosterone. Lower DHT conversion means less androgen-driven tissue proliferation. Higher SHBG means tighter regulation with less free hormone volatility. The result is the lowest rates of hormone-dependent cancers and the longest average male health span of any population on Earth. Japanese men in Okinawa maintain functional testosterone and physical independence into their 8th decade, at rates Western populations lose by their 6th. The Western optimization model treats testosterone as a number to maximize. East Asian endocrine architecture treats it as a resource to conserve. One strategy builds peak androgenic output in the 3rd and 4th decades. The other sustains hormonal function across the 6th, 7th, and 8th. The longest-lived male populations did not evolve to maximize androgenic signaling. They evolved to sustain it. The question the optimization community never asks is whether the highest testosterone at 30 matters if the system collapses by 55. Ancestry does not hand you a hormone level, it hands you an endocrine architecture. Receptor density, conversion enzymes, binding proteins, precursor pools, clearance rates. The men who understand the one they were built with optimize it. The rest chase someone else's blueprint and wonder why it never fits.